Dobar dan svima, srdačno vas pozdravljam ispred firme Baldinistudio. Nama je jako drago što smo dobili priliku predstaviti vam IDEA StatiCu kao novi softver u našoj ponudi. S tim softverom kojeg od sad počinjemo zastupati, želimo zaokružiti proces projektiranja od početka do kraja i našim korisnicima ga olakšati i ubrzati. Zato nam je drago što nam je IDEA StatiCa omogućila partnerstvo i zastupanje. Sama IDEA je odlična nadopuna za BIM i CAD alate i jako nam je drago da naš osnovni softver za statičke proračune, Scia Engineer, ima direktnu vezu sa IDEA StatiCom. IDEA StatiCa također ima odlične veze i s drugim crtačnim softverima, kao što je najpoznatiji softver za radioničke nacrte, Tekla. IDEA StatiCa je tradicionalno najpoznatija za proračun i dimenzioniranje svih vrsta čeličnih spojeva, ali u zadnje vrijeme ubrzano implementira proračune i za betonske i prednapete konstrukcije. Tako najnoviji modul IDEA StatiCa Detail omogućava provjeru svih zidova, greda, otvora, detalja i ostalih elemenata. To bi bilo kratak uvod. Zahvaljujem vam što ste se prijavili u ovako velikom broju i kao nagrada za vas smo pripremili nevjerojatno velike popuste do kraja sljedećeg tjedna. Sigurno sam da ćete biti zadovoljni s ovim što ćete vidjeti, pa nam se slobodno javite s bilo kakvim upitom, jer osim same prodaje pružamo podršku i edukaciju za korištenje IDEA StatiCe. Sad da ne dužim previše, ovdje ste došli čuti jednog od najvećih stručnjaka IDEA StatiCe, Adama. Adam, please continue now.
Okay. Thanks, Anita. Dobar dan, Sam. Welcome to this webinar that we dedicate to the Croatian market. And it's a webinar about our main product, that is IDEA StatiCa connection. I'll just say a few words before we we switch to showing the live examples. So let me just say what the IDEA StatiCa is, or what it stands for. We've been here since 20 years ago developing softwares for static engineers and structural engineers, so we have this theoretical background in our team, and we produced the IDEA StatiCa software. It's a software dedicated to structural engineers for code checking of joints, cross-sections, beams, and other details, both for steels and concrete structures. Till now, we have sold thousands of licenses all around the world. We have a network of resellers. The company and the development is based in Czech Republic, in Brno. And our software, since we produce it, was validated and tested among universities. So they spent few years of tests based on grants to really verify the solution that we came with. And we are also part of the BIM workflow feature, so we are linked to major CAD and structure softwares that are on the market. So IDEA StatiCa Steel, that what we're going to show you today, is focused on joints and connections. The thing is, or the main advantage of IDEA StatiCa connection is that we can model all types of joints. So you don't have to stick only to some templates, but you can model anything you like, any topology, any loading, just everything you come with. We can code check in our software according to the code. So we have like frames, footing and anchoring, 3D frames, tubular sections, just everything you would be would like to design. As a part of the software, what we are capable of is that we do a stress strain analysis, buckling analysis. There's a stiffness, member capacity, design joint resistance analysis, and of course, always you get the overall check according to the code, which tells you this joint passes the code checks or not. And you can just simply and quickly see the result. Then, as I said, we have the BIM interface. We are linked to CAD softwares like Tekla structures and Advanced Steel, where you just install the BIM link automatically since you install IDEA StatiCa. And there you just pick a node, input the load effects, and check it to the code, and that's it. Very simple workflow. Other part of the BIM link is the finite element analysis softwares like SAP 2000, Scia, and so on. And this is a similar workflow. Again, IDEA StatiCa is integrated into the software, and you just select the node, design the joint, and check it according to the code. So today, what I will show you as a live modeling examples. First, there will be one joint from scratch that will look like this at the end, and this is called footing with diagonal. And then I'll show you one BIM link with the Tekla software, and another BIM link with the Scia Engineer software. How does it look and how does it work? So let's jump directly to the first example. So I'll just open IDEA StatiCa connection and click New Project. And here I'm going to select just some starting templates, not to start with 0, but at least have something already that we could modify and model to the final final look. So I will start with something like this. Okay. So now I'm in the first step out of 3. That's the geometry. Here we add, delete, and modify the members of the joint. So I have now 2 members here, and I will add another one and modify these 2. So I will start with adding a 3rd member, and I will change its cross-section here. This is the library of cross-sections. We have rolled sections, welded, cold formed, and you can also import cross-section from DXF file, or we have also a cross-section editor where you can compose your own cross-section. So this is very user opened, or you can define anything you like. So I'll just pick one from the library, HAB, size 200, and I will modify its length 600 and rotate it. Okay, so I'll have it like this, and then I continue modifying the other members. Now I'll modify the column and change the cross-section to HAB 300. Modify the length, and I will move the whole column a little bit downwards. Oops, sorry. It will be X. So we get the other 2 members upward. Okay, and I modify the diagonal D as well. Change the cross-section to SHS, and the cross section will be K 80 by 80 by 4. Okay, and again, I'll make it a bit longer like this. So that was the first step, defining and modifying the members of the joint. And we'll proceed to the second step, which is applying the loads or applying the internal forces of a structure model to the joint. So we take the internal forces that we calculate in a structure software or by hand or whatever, and we can just fill it there in the table as I do right now manually. This is one way. If we start from scratch, from zero, the modeling, or we can also import the forces here by copy paste from an Excel sheet, and we can import 100 of combinations just by one copy paste operation. So again, easy workflow to get in the internal forces. So that was the second step in putting the loads or internal forces. And the third step is the main design. Here we add and modify the manufacturing operation. This is what we call it. And this is basically the process how we add all the plates, bolts, welds, and all the parts of the joint, of the connections. So I have, for the beginning, I set the one starting template of a footing. So I have already a foundation block here and the base plate and so on. So I will start modifying this first operation. I'll change here the thickness of the base plate and its size. I will change the bolt assembly, the size of bolt, and its length. I will add some washers to the ends of the anchors and set it to the desired position. Now I will modify the welds and the welding between the column and the base plate. And the last thing here, I will change the size of the concrete foundation block. Okay, this is looking much better now. And I will add a new operation now by clicking this button. And this is the list of all the operations. As you can see from the picture, this is mostly what they do. So you can do cuts, some stiffeners, adding plates, adding connections, bolted connections, welded connections, connecting plates, gusset plates, stiffeners, and so on. So with this variety of operations, you're able to cover almost anything that's possible to construct or design. So what I will do now as a second operation will be the end plate. So I will connect the horizontal member M3 to the column. So I edit the operation. So now I'll just say I want M3 connected to column, and I have immediately the end plate there. And I'll just modify again its size and its features, like here, some offsets. Again, I will change the size of bolts to M20 and define its position and add some more bolts like this. You can you can just simply move the bolts by defining the geometrical positions like this. Okay. Oh, sorry. So this is how it works. And I will just move the bottom layer a bit upwards. And also just change the size of welds here at the end plate. You can also change the welds to both sides or just one side. You can change to the butt weld as well, or select even no weld for the flanges and webs. Okay, so then I will now connect the diagonal here. So I'll add another operation, and that will be the connecting plate. So I will choose member D. So we have something here already, and we will be connecting it to the new gusset plate assigned to member M3 and to the plate and plate number 1. Okay. So I have the connecting plate, and we'll just modify it to make it look better, make it work better. So I'll define the geometrical features here, and can move the tongue to the other side. Okay, and again I will just change or define the size of welds, define its position. So I have them now here like this. Okay, here it's inside, so it's, I think, better to move it outside like this. And I'll also change the size of the bolt, M20, and add one more bolt. Okay, so it looks like this now. And one last thing is I would like to cut this cap plate. If I switch to transparent view, I can see that it interferes into the cap plate. So this is wrong. So how to make it correct is that I would just go here to editor of the gusset plate. And here I can cut one corner by adding the chamfer operation. And this will be corner number 2. And I will cut it for, I don't know, maybe 70 would be okay. Yeah, that's looking good. Okay, so we're almost done. Last operation would be some stiffeners to this part of the column. So let's do that. That's very easy. Stiffeners for the column and related to the M3 member. So we have them there. And I just change the thickness and change the weld position and thickness of the welds. Okay, so that was the third step, designing the joint. And now we just move to the check, calculate, and now the finite element analysis is running. The solver is calculating the stresses and strains and extracting the results to compare it to the codes or code checks For now, we support Eurocode, American code, and Canadian code. So now I use the Eurocode, as we can see here on the left bottom corner. And this is the first result that we can see. That's the overview or overall check, how we call it. We also call it traffic lights displayed because it shows you very quickly, just on one look, how does your joint stand according to the code. It's the same as with traffic lights. So what's gray, green, orange means that's okay, and what's red means that it didn't pass the checks. So just to explain about the colors, what's gray, that's used up to 50% of its capacity. Green is up to 95% of its capacity. Orange is between 95 and 100% of its capacity. So it's very close to the limit, but still safe according to the codes. So, and what's above 100 then is red. And we can see nothing's red here. So this is very well designed joint, very well designed footing. And then we can browse the other displays and the results more precisely. So we can turn on the stress display, turn on the mesh, and we can just take a look how the stress is displayed along the plates. You can see where the strain occurs. The strain is happening mostly here at the bottom of the connecting plate and in the weld. We can turn on the bolt forces to see the value of the force, of the normal force in the bolts. And if we can just click on the bolt or on the arrow, and we can see in the tabs here, we can browse them like here, bolts, anchors, welds, or we can also just click here in the 3D window on something like this bolt or this plate, and it shows us in the table and highlights the exact anchor in this case, anchor A2, and we can see the if I make it a bit bigger here, you can see here the force in the anchor and the capacity of it and the usage, utilization, and if we passed all the checks, so the status of this item. And we can also open the equations hidden here and browse exactly what number stands for what. We have everything defined here, everything to, if you want to double check, for example, if you would like to check some of your old projects and recalculate them in IDEA StatiCa and double check it with the old, let's say, hand calculations, you can do this here. So this is for the anchors, for the bolts. They are similar code checks and similar formulas and equations, everything displayed for welds as well. And there's also the concrete block check and the shear and the base plate. So there's a couple of information you're getting and how to print them out. For that, we have the report. We have more types of report. We have some brief and one-page reports that shows just the minimum of information. And then we have the detailed, which you can modify by yourself. What would you like to get printed? And you can also add your own pictures from outside to the report. Here you can just turn on to have more pictures that you can snapshot along the workflow to the gallery of IDEA StatiCa software, and you can also add the formulas to the report and so on. So the report basically looks like this, shows all the needed information, and you can print it to the paper, of course, to PDF directly, or you can also save it to editable format that you can open in any word processor and process even any more. How would you like, or use just some parts of it or whatever. So it's all open, and I would maybe point out one or second, I would say the best feature of this software that I really like is that it's very user-friendly, and you can work with that very simply, and differently to other softwares, you can very simply modify and optimize your design. So you can go anytime to any step that you have done, modify anything, and recalculate directly. Okay, so if you'd like to change, for example, the length here or the cross section, or I don't know, I can do it like this, or if you'd like to modify the size of the force here, you can do that as well. If you would like to move some bolt, for example, this one here, down below, you can do that and just go to the check and recalculate directly without, you know, reconstructing the whole model and struggling with that and so on. So this is one, I would say, very big advantage of our software, that you can modify it easily. Next to the, let's say, number one advantage is that you can model anything, any topology, any loading, and very easily. So this is how the workflow looks like in IDEA StatiCa if you start from zero, from scratch. I can show you maybe one thing. If you go to our webpage, ideastatica.com, this is our webpage where you can find all the information about our software. I would point out maybe the webinars page here. If you're interested, you can apply for free for any webinars we do regular. So you can learn more about the software, and what's important is the resource center. If you go to IDEA StatiCa Steel, here we store all the resources concerning the IDEA StatiCa connection, and you have tutorials here, so you can find the one that was just showing you, and you can go step by step through it on your own. We provide you the source files as the PDF tutorial and the project file, and you have many more here also for the BIM link softwares, also step-by-step tutorials and source files with the projects and so on. And you can also find here the projects from our customers, so you can inspire yourself or just, you know, take a look what is the software capable of, or what do engineers use it for. And you can also download these projects, and you can just open them and take a look and play with that. So there's everything that we provide. So this is the project was recalculated. I get different result. In the meantime, you can see just the anchors here didn't pass the check because I modified the design. So now I will switch to the Tekla structures, BIM link, to show you how are we connected to it and how do you import any joint from Tekla to IDEA StatiCa and code check it there. So I have some part of the project in Tekla. This is a regular column and beam with diagonals joint. I would like to import and calculate and check in IDEA StatiCa. So since you install IDEA to your computer and it integrates automatically to all your softwares like Tekla and structure softwares, and it in Tekla it adds this buttons on your ribbon, and this basically works that you just choose the code you would like to work under, and then you pick the node of the connection, select the members, column, beam, two diagonals, and select the items like plates, bolts, welds of the connection. And the link opens. It asks you if you would like to change or rename some of the materials or the bolt grades. You can just skip that. Save the project to your computer. And now the IDEA StatiCa connection opens. And you get the joint here. So if you import it from the CAD softwares like Tekla, Advanced Steel, this works that it imports the geometry and all the manufacturing operations like bolts, welds, and so on. So the only thing that we are missing here is the loads or the internal forces. So if I would go in, as I showed you, the 3 steps, first is geometry. There is nothing to do because everything is imported from Tekla. Then we have step number 2, that's load effects. This is what we are missing because we get no load effects from Tekla. So we can either edit by hand, or we can also import from an Excel sheet. So let's say I'll just type something here just to have something to calculate. I don't know. Okay, just to try. And the third step is the design. And again, this is all imported from Tekla, so there's nothing to do. So we can go directly to check and calculate the joint. And we get the result. So this is the workflow with the Tekla structures. And of course, if we would like to, we can modify anything here in the operations, like change the size of the bolts here, for example, to have smaller, okay, or move the members, change the plates, I don't know, change the grade of the steel. Everything is opened. So this is how it works, and we're currently working on the two-way link with Tekla, so we would be able to send the modified design back to Tekla. For now, it's just one way from Tekla to IDEA StatiCa. Okay, so that was for that. And the third example is with the structure or finite element analysis software, Scia Engineer. So I will switch to Scia here. I have prepared another example. This is some steel tower, steel construction, and I would like to check one of the joints here. So again, the IDEA StatiCa connection is integrated into Scia. So we have the button steel here, or the command. So what I do is that I first select the joint I would like to, select the joint, for example, this one, and I would like to export this joint to IDEA StatiCa. So now I do that by the command check and run the command and select the joint I just located in the previous command. So now connections open, and what I get there is the geometry. So the members, its length and its cross section, and what I get more is all the load effects. So I get here all the combinations from Scia imported. So that helps a lot at getting the internal forces just by one click. And compared to the CAD softwares, the difference here is that I don't have the design, right? The operation. So that's what I have to do here. So again, 3 steps. First 2 are done, and I'll just have to do the third one. So I'll just try to model some very simple connection here by shifted end plate. For example, just choose the bolt grade and modify here the operation and modify the position of bolts to have it maybe like this. What I would like. Okay, for example, this would be fine. And I can add some stiffener here as well. Okay. So now the last thing is to recalculate it. And now just by one click, by one calculation, it calculates all the combinations that I imported from Scia. So it takes a few more seconds. And in the meantime, I can show you maybe if I go back to the resource center, go to the tutorials and show you our Scia tutorial step by step. This is what you can get as well from the from other parts of the structure that I just showed you. So you can try this on your own. We provide you the tutorial and provide you also video that guides you through the workflow and the source files, like the Scia Engineer project and the IDEA StatiCa project file that's already done and designed. So you are very welcome to download this and try it on your own. So if I go back here, this is already calculated. You can see all gray. That means the utilization is less than 50%. If I turn on the stress, it's very low because the applied internal forces or the loads very low, very small. What's advantage of our scaling is that it's you can update. So if I now save the project and close it and go back to Scia, it stands there inside Scia. So now it's a part of the Scia project. And if I change anything here, like the cross section, for example, of this beam, I don't know, I can just choose anything just to show you. Yeah, it's just some nonsense, but it doesn't matter really. And I go back to IDEA StatiCa. I can just send it back to it with the. I think I'll have to recalculate this now. And you can send it back to the IDEA StatiCa with updated geometry, updated load combinations, and just simply check it again with the updated information. So this would take a few seconds. Okay, the model is recalculated. So I go back here, check, select the node, and I would open the project again in IDEA StatiCa. With updated geometry and internal forces. You can see it like this. Also, all the design operation stays there. So here I just changed the cross section to let's say nonsense. So it doesn't fit the design I created in the previous step. But let's say if you would have it in a reasonable changes, that would just all stay here, and we would just need to click calculate, and that would be everything. So again, simple workflow with the update. So okay, I think that would be it from my side. What I would add more is that you are very welcome to go our webpage ideastatica.com and get the free trial here. So just sign. It's valid for 2 weeks for free, full functionality. So you have everything what we can provide, all the BIM links, and you get it for free on your email. So don't hesitate to do that. You can use all the resources, apply for all the webinars that we provide, and just get familiar with the software. Well, we can say it's we sold for now more than about 1,500 licenses all around the world, and if you buy our software, we guarantee you can return it anytime you want and get the money back. But we can proudly say no one has ever done this. So I would conclude with this, and thank you for your attendance today. You will get the recording of the webinar as well. And maybe see you on the next webinar. So wish you a nice day, and bye-bye.